Welcome back to Maths with Mrs. J. This will be my final video for now anyway in my series on complex numbers. We've talked about de Moivre's theorem. I wanted to introduce you to Euler's theorem. Some people refer to him as Euler, but he was German, so it's pronounced Euler, and his identity. This stuff is really cool if you're a bit of a maths nerd like I am, which is nothing to be ashamed of. Euler says that if theta, as long as theta is in radians, then our cis theta, which is our polar form without the r, if r is 1, is the same as e raised to the I theta. That's pretty groundbreaking when you really think about it. So they're saying e to the I theta is cos of theta plus I times sine of theta. That's what Euler is telling us. Remember, E is that very special transcendental number. You might recall from our derivatives and integrals that derivative of e to the x is e to the x, and integral of e to the x is e to the x plus some constant. It's a very, very powerful, cool transcendental number because it also comes in here. Let's just prove Euler's identity. We're proving that e to the I pi plus 1 is 0. Well, let's have a look at our left-hand side. So our left-hand side is e to the I pi plus 1. Well, according to Euler's rule, e to the I pi will be cos of pi plus I sine of pi. So that's the e to the I pi part, and then plus our 1. Let's just think back to our unit circle business. And yes, I know I keep harping back to this, which is why when we learn it the first time, we should really try to master it if we can. We're at pi here. Cos of pi is -1. Sine of pi is the y value, which is 0. So we're going to get I times 0. So we've ended up with -1 plus 1, which is 0, which is the right-hand side. So we have proved it as required.